Good morning to one and all present here. Myself Satish, Assistant Professor, Department of Mechanical Engineering, Akshaya College of Engineering Technology. In the part 1 video, we're going to see about what is the system of limit, fits, tolerance and gauges. That topic is belong to the subject Metrology and Measurement ME3592. Specifically, we're going to see about what is terminology of BAS in this part 1. Here you can see the picture over there. It's a mobile phone, but we won't call it a mobile phone because it's a disassembly of the mobile phone. We will tell there is a RAM over there and a RAM over there, the flash IC over there, the charging unit over there, and then crystal oscillator over there, and then audio IC, logic IC. We will tell only in the part name only. Here we're going to see the car, the disassembly of the car. Okay, you can, for example, the wheel over there. The wheel also it's not a single product. Okay, it's made up of assembly of the tire, tube, and then alloys. The cars are made up of many parts that work together to perform various functions. Here the introduction. We know the fact that the two things, no two things can be in the similar in the nature. Okay. Even for the identical twins, we can see the so many difference. Okay, if the in visual you cannot see the difference, even if the using the measurements, definitely there will be the some deviation over there. Okay, that's why they are trying to tell no two things can be similar in the nature. Every process in the combination of the three elements, every process is a combination of the three elements, that's a man, machine and material. Okay, any changes of these, it will constitute a changes in the process. All these elements are subject to inherent and characteristics variation. It's not impossible to produce a part to an exact size. Okay, then what you have to do means you have to ask some allowance, that known as the tolerance. How much tolerance can be allowed? The tolerance allowed depends on the functional requirement. Okay, if you're going for the engine assembly, the tolerance is different. For the mobile assembly, part assembly, the tolerance is different. Okay, if you're going for the piping, plumbing assembly, the tolerance may be the different. Here for the example, you can see the picture, the 3D picture, the shaft, bush, and then the oil over there. You can see the oil hole in the product. Its a shaft has to rotate in the bush. There must be the enough clearance between the shaft and bush to allow the lubricating oil film to maintain. Okay, if you pouring the oil, what have to do, the oil have to spread to the shaft, then only it will work properly. Okay, if the excess heat is there means it will reduce. If there is any friction also due to the oil, it will reduce. If the clearance is too small, what will happen, the excessive force would require for rotating the shaft. The force, if you're giving the shaft, if you're giving the too small clearance, in other hand the clearance is too large means what will happen, the vibration will come. Okay, next we're going to see the terminology as per the BIS, Bureau of Indian Standard, publishes Indian standard codes that include terminology for variety of product, process and services. In terminology, first we're going to see about what is the size. Okay, simple we can say it's a number expressed in the particular unit. For example, the scale over there, the pencil is there, the size of the pencil is 8 centimeter. You can call it as a 80 mm also. Okay, size is it's a number expressed in the particular unit. Okay, 8 centimeter or 80 millimeter. Okay, you can use either of it. Next, you're going to see the basic size. It is a size based on which a dimension deviation are given. Here in the picture there is a size of 25 over there, and another is a 18, diameter of 18, that denoted as a hole. The future is a hole, and there is a tolerance also they given, plus or minus 0.5. You can see 18 plus or minus 0.5. Here in the another dimension 25, there is a no tolerance is given like the plus or minus. Then simple we can say the size based on the dimensional deviations, it's a basic size. Here the actual size. Okay, what is the actual size mean? The component by the actual measurement after it's manufactured. After the manufacturing, what is the measure value that should lie in the limit? If I am telling the 18 plus or minus 0.5 means the value should be in the 18.5 or 17.5. Here the limits of the size, you can see the what is the limit. There is an example we are seeing the 18 plus 0.5 is a maximum limit, 17.5 is a minimum limit. Either maybe it's shaft or hole. Shaft means the minimum size will be the smaller, the maximum size will be the upper limit. Okay, here we go for the deviation. You can see the deviation, the lower deviation, upper deviation. It's an algebraic difference between a size to the corresponding basic size is maybe the positive or negative. Here I can see the deviation, the lower deviation, upper deviation of the shaft, and then in this side, left hand side, you can see the lower deviation, the upper deviation of the hole. The maximum limit of the size is upper deviation, the minimum limit of the size is lower deviation. Okay, next, fundamental deviation. Simply we can say they can see the zero line in the red color mark over there. Okay, it's a reference you have to take. The deviation, neither the upper or lower deviation which is near to the zero line. Okay, maybe the upper limit deviation or lower limit deviation, which one is nearest to the zero line of for either the hole or shaft, the it fixes the position of the tolerance zone in the relation to the zero line. Okay, which nearest to the zero line we can tell it's a fundamental deviation. Okay, what is zero line? Here the shaft and hole over there, the graphical representation of about term, the zero line represent the basic size. The line is also called line of zero deviation. There will be the no deviation in the zero line. Okay, that's what they are calling as a line of zero deviation. Okay, next part 2 we are going to see what is tolerance and then why we are going for the tolerance. Thank you so much.